put an alarm on my phone. So. Okay, so last class we talked about 1.4, and we said that the steps to solve linear equations are: first, we simplify both sides of the equation. Next, we collect all variables on one side of the equation and all constants on the other side, and then we isolate the variable and solve. So we did a bunch of examples like that. All right, so now we're going to do another type of example where we're going to do B, which is linear equations with fractions. Okay. So let's do an example. So we have 2x plus 5 over 5 plus x minus 7 over 2 equals 3x plus 1 over 2. Okay, so first thing we're going to do is we're going to, so these types of fractions that we're doing, the denominator is the bottom of the fraction, right?
Yes.
Did we talk about that in this class? Let's just write a little note so we're on the same page. A over B. The top is the numerator, and the bottom of the fraction is the denominator. So that way when we're talking about numerator and denominator, we're all on the same page, right? So in these examples, the denominator is going to be a number. Okay? So in order to get rid of that, we want to multiply by the least common denominator. So step 1 is multiply by the least common denominator. Okay, so 2 and 5, what are 2 and 5 a factor of? 10. So we can multiply it by 10. So if I multiply 2 times 5, that's 10, right? So I'm going to multiply both sides of the, or I'm going to multiply the entire equation by 10. And the goal of multiplying by the least common denominator is to cancel the denominator. So let me write that. To cancel the denominator. That's the goal. So for this first problem, I'm going to distribute this, right? So I'm multiplying everything by 10. So I'm going to put 10 in the numerator, and I'm not going to do anything else quite yet. So I'm going to write 10, and then I am copying what I have. I can multiply anything by the whole, whatever I'm doing to one side of the equation, I'm doing to the other side, so I can do that, right? Okay, what is 10 over 5? 2. Here, what is 10 over 2? 5. Here, what is 10 over 2? Okay, so let's rewrite what we have. We have 2 times 2x plus 5 plus 5 times x minus 7 equals 5 times 3x plus 1. So the whole reason I'm I'm multiplying by the least common denominator is to cancel the denominators. How do you spell cancel?
C-A-N-C-C-E-L.
E-L or L-E? I can never remember.
E-L.
Shouldn't have asked. Should have just gone with it. Okay, so do you see what we did?
Is it okay if I just went straight to what you have right now instead of doing the 10 thing? Or no, do you want to do
I want you to show me that you're multiplying the whole thing by 10. You don't have to do this step. This is just to show that step. If you went from here to here, saying I'm multiplying everything by 10, that's fine.
This looks like an extremely confusing way of just multiplying. Will you I don't like fractions.
Nobody likes fractions.
Yeah.
That's why we're getting rid of the fractions right now.
Yeah, so you multiply that by 10. Is that just a way of... my brain's working through this. Hold on, sorry.
So I multiplied the entire equation by 10 because I want to get rid of the denominator. When I multiply by 10, I have 10 over 5, which equals 2. Here, 10 over 2 equals 5, so I'm simplifying.
Okay.
So is this okay?
Yeah.
So now I'm back to a linear equation, and I'm back to those 3 steps that I had on the first page, right? Simplify both sides of the equation, and then get everything with an x on one side, everything without an x on the other side, and solve, right? So once I've multiplied by that least common denominator and canceled, like I just did, then we're doing what we've done before. What we did all last class, right? How do you feel about that?
It makes sense or no?
Okay. So now I'm going to distribute. I'm going to distribute here, here, and here. So I have 4x plus 10 plus 5x minus 35 equals 15x plus 5. So now I'm going to simplify my left side first, right? I'm going to combine my like terms. I have 10 and I have negative 35. And then I have 4x and 5x, so that's 9x minus 25 equals 15x plus 5. Okay, so I've simplified both sides, right? As long as I can add, I've simplified both sides. I get everything with an x on one side, everything without an x on the other side. That's the next step. So tell me what you guys got. Who wants to tell me the next line to write?
I have 25 and 5 to 5, so you can cancel out the first 25.
Good. Blair. So I have 9x equals 15x plus 30. I'm going to tell me the next step.
Now you
Subtract
subtract 15.
15x from both sides. Right? And here, while I'm doing this, I'm thinking I'm combining my like terms, right? So I have negative 6x equals 30. Now what?
You divide negative 6.
Divide both sides by negative 6. And what do I have left?
Negative 5.
Good. All right. Carson, what's your homework question?
Oh, that's pretty much good now. That makes sense.
Let's do your homework question.
All right.
So that was example 12. This will be example 13. So the only new step we're adding to this is multiplying by the least common denominator in order to cancel the denominators.
Yeah, it's like the same question. So,
Same exact?
well, not the same exact one, but like the same form.
Yeah.
We used to do that.
Let me see if there's a better one. So do you want to do this?
Yeah, that's fine.
Okay, let's do it. Can you hold it? So I don't know where to put it. X plus 7 divided by 6 equals 5 over 3 plus x minus 9 over 4. Thank you. Okay, so the first step is to multiply by the least common denominator. How did you get 12, Blair?
Because 6 times 2 is 12, and 3 times 4 is 12.
Good. So I'm seeing what multiplies to all of these, right? So I think it's called the least common multiple. Okay. So 6 equals, so I'm going to write down all my denominators, and I'm going to write out the prime factorization of each. Have you guys done this before? Is this too much? Can you see that it's 12?
Where did 2 come from?
4 is 2 times 2. So here I wrote down all of my denominators, 6, 3, and 4. And now I'm going to do the prime factorization of each. So 6 is 2 times 3. 3 is already prime. 4 is 2 times 2. So I'm going to combine these. Well, I have a 3 here. I have a 2 here. From here, I already have a 3. From here, I have 2 2s, so I need to put another 2 in here. So I'm combining all the prime factors. So you guys might have already seen that it's 12. This is why it's 12. Because you're combining all of those prime factors. Right? I'm going to the first one. I'm writing all of the prime factors, 3 and 2. From here, there's a 3. I already wrote 3, so I don't need to write it again. From here, I have 2 2s, so I need to put another 2 on there. 3 times 2 times 2 is 12. That's how we get our what we're looking for. So I'm going to multiply everything by 12. I'm going to write out that step where...
I have a question.
Yep.
On the test, do we have to write out like that?
This?
Yes.
No.
Okay. Because I just looked at it.
So the thing is I like to write this out because if you guys have to take college algebra, I'm not sure if we'll do it in this class, but if you guys have to take college algebra, what if your denominator is like x plus 2? Right? So sometimes it's easy to go back and to remember what we're doing with numbers. So that way if we had like x plus 2, then we could see it. Okay, so I'm going to write that one step out where I say it's 12 times x plus 7 over 6 equals 12 times 5 over 3 plus 12 times x minus 9 over 4. So now I'm going to simplify. 12 over 6 is what? 12 over 3 is what? 3. So now I need to distribute. So let me write what we have. 2 times x plus 7 equals 4 times 5 plus 3 times x minus 9. Okay, so you guys solve it. Somebody tell me what the answer is. I'm going to write down mine. But only look if you need a hint. Try to do it on your own. check my work when you're finished. Did I get it right?
Yep.
All right. So now we're going to do another problem, number 14. So I have 2 times x plus 1 equals 2x plus 3. So let's solve this one. So again, I need to simplify both sides, right? So on the left side, that means distributing my 2. So I have 2x plus 1 equals 2x plus 3. All right, let me subtract 2x from this side. And I get 1 equals 3. Is that a true statement or a false statement?
False.
False. So what does that mean about my solutions?
They're going to be false.
So, okay. Thank you, guys.
I was like,
Still false.
Okay.
So it's still false. So what does that mean? 2 does not equal 3, right? So it's false. So that means no solution. Or inconsistent. Okay, so if you ever get down and you're solving a problem and you get an incorrect statement, that means it's inconsistent.
231.
I'm going to do this problem. I'm going to do one more. 15. Let's do 4x plus 6 equals 6x plus 1 minus 2x. Okay, so first step is I need to simplify both sides of the equation, right? So on the right, I need to distribute and combine like terms. On the left, I can't do anything to simplify. Okay. Okay, so on my right-hand side, I need to combine like terms. Okay, so now let me subtract 4x from both sides. And then I get 6 equals 6. Is that a true statement or a false statement? True, so what? Has infinite solutions. Good. So a true statement means it's consistent. It's the identity. And the solution is all real solutions. So all solutions. Right? All solutions because I can plug in any value for x and I'm going to get a true statement. And we talked about this, right? That means all real numbers. When you were doing your homework, what did it say?
It said the
Identity?
inconsistent or
Yeah, it was like inconsistent and then like infinite solutions, like just terms like that.
Okay, so infinite solutions, all real numbers,
yeah.
things like that. Inconsistent, another way to say that would be the empty set, right? We talked about this?
Yeah.
So those could be options for this. This is all real solutions.